Um, so I'm Josh Piori. I'm a researcher. Just a little bit. With OpenDNS, I used to. Well, I was. Well, it's still OpenDNS, but we were purchased by Cisco. So I'm with Cisco now. Um, I used to work at NASA. I helped build the Security Operations Center and was a threat analyst. Worked there for about 5 years. Worked at Mandiant for a year and stuff like that. So the world is a magical place, as we all know. We had the internet. It used to look like this when it first started. It's just a small number of nodes that kind of look like that as well. This is probably in the 70s, sometime in the 70s. Um, Mainly connecting universities and some important places. Um, I tried to map, every domain to ASN and crash my computer, so I didn't do that. But here's a little sample of what it looks like. There's, ASNs are the, not domain, but IP. ASNs are the network owners of IP addresses. And so I just tried to map a whole big bunch of stuff, and you can kind of just get an idea of connections. But if you want to see, there's a way, there are other services that are mapping the internet, so you can see the general size of it. In this case, according to this source, they are showing the United States is the largest owner of internet-connected devices, and it moves down this list, basically. Here's another way of looking at it, a really pretty view, but without the labels, there's not much context. But there's a whole bunch of insecurity with all this stuff. First, I'll talk about SSL just a little bit. I won't go too deep into all the vulnerabilities, but I'll give a little bit of information. And I'm sure you've heard of almost all of them. I hope you have. There's Poodle, which is a attack against SSL, a certain version, version 3.0. It was a man-in-the-middle attack. You could send a certain amount of data to SSL and force it to downgrade to a different version, and then affect the act as a man in the middle and get data and change data and things like that. Then of course there's Heartbleed, which is a big one a few years ago, 2014. There's a bug in OpenSSL, another implementation of SSL. It was a buffer overread, so it was found that you could send more data than it could handle and execute arbitrary commands. It affected clients and servers, so servers being, your banking website. Yahoo is not a banking website, but websites that use SSL certificates, and clients as well. So lots of software uses SSL. You can modify things like post data and user requests. So if someone's sending something to their bank, you can modify that data. Session cookies, you could steal that stuff. You can see passwords. You can steal private keys. And if you have that private key and the company hasn't changed it after fixing Heartbleed, if they even fixed it, you can still access all this secret stuff. It affected all these companies and a whole lot more. So there's like Reddit's up there, Yahoo. You don't want anyone to read your Reddit history. So LastPass, that's not a good one to affect. There's reverse Heartbleed. This affects the client systems. So clients being applications. You can read client memory, things like that. It affected all sorts of things like MS SQL, VMware products, Juniper, ton of different Linux versions, distributions, so pretty bad. Then there's Shell Shock, which was also 2014. So Bash is used in a lot of internet-facing services. This is the command line, but it's utilized by things like CGI web servers and OpenSSH servers, DHCP clients. It'll actually take the request from these services and process them on the system. The thing about this was that the attacker could send extra data and do all sorts of stuff. There's SHA-1, which is a hashing algorithm, a secure hashing algorithm. So if you look at like this one that I made, it's that long number is is supposed to be a unique identifier for that phrase. It could be for a file, but the thing is that if you have a unique identifier, it's not supposed to be repeatable. If you take a separate file, you should get a different number. dates back pretty far back to 1995. And it's been known to be vulnerable to theoretical attacks since 2005 because that number just isn't very complex. It was banned by NIST, for use, federal use in 2010, and digital certificate authorities, the companies that issue you those SSL certificates, were banned from using certs, using SHA-1, those better SHA algorithms now. And actually, it's proven just, I think it may have been last year, it could have been 2 years ago, that a SHA collision was shown to be possible, and some researchers made it so that you could upload a file and upload a different file and get a collision, so they both have the exact same SHA. So that really showed people that SHA-1 cannot be used anymore. We have WEP, which hopefully you all know it's not really secure. It's supposed to provide data confidentiality by encrypting your wireless communications as of 1997. It used a 40-bit key, so not a very long key, with a 24-bit initialization vector. So this is a way for it to kind of sorry, I'm losing my train of thought there. To keep it so you don't have clashes. Helps prevent repetition across the devices, basically. But that's not long enough. It's really easy to capture that key. There's a pretty high probability that after a certain number of packets, you can crack that and get that key and break into the network. Of course, there's WPA2, which is after that and has been considered very secure until fairly recently, when some researchers released a paper, this is about 2 months ago, maybe a month and a half ago, that you can crack it fairly easily. So it takes advantage of another secure key management vulnerability just like in the initialization vectors, but it's different. Like I said, I'm not going too in depth to everything, but they can then, once they get into that, they can man the middle of the connection, something that people think is very secure, and it's affects everywhere's running WPA2, like in cafes and whatnot. They aren't usually doing more robust stuff. But of course, there's Blueborn, which is Bluetooth vulnerabilities. Pretty amazing what these researchers found. I took some of their videos so I could show you. In this case, they have this top window is what the hacker hears, and I feel like I'm preaching to the choir. You're probably all seeing all this stuff, but I'll keep going. So you have what the hacker's going to hear, while on the hacker screen they're going to be connecting to a Samsung watch. So, and you can't hear it because I don't have any sound on this, but they're playing some music, and they're just messing around on the phone, playing the music through the phone, I guess. And this attack is beginning over here. They're running a Python script that they wrote, and they're opening the microphone, or they're dropping into a shell, but they're going to connect to this device which they've never connected to before, and they didn't have to do any kind of pairing mechanism. They're able to open the microphone at this point, and at the top they have the wave file coming through, so they can listen over the network to what's playing between this watch and this Bluetooth speaker. And the user has no clue. They can also reboot the watch. They could do other stuff like that, but listening's a pretty big deal. There's another instance where, in this case, they're going to connect to this Google Pixel phone, and they can wake it up, and as you'll see, they use like a remote mouse, and they open a camera app, and switch it around, take a picture of this person sitting there who, I guess they're not looking at their phone, but and they can store that image locally on their system, and they can see the image. And then there's this example too, which is just a Windows machine. If you look on the top right, there's no connection of any kind. They start their attack and their connection, and you'll see there's a connection up there, and then they can force all their requests to a certain domain to go through them, basically. So they're doing like a fake MSN sign in, a fake Google sign in, and when the user finally gives in and just types their password, that data is transferred to the attacker. So and all through Bluetooth. So there's been a lot of vulnerabilities with Apache. This is just a scrolling list of how many there have been. More interestingly and more well known is Adobe. Looking at Flash, or they have a lot of products. Flash is a huge one. Shockwave is a huge one. It's almost like for a period about 3 years ago, I remember there was like a new vulnerability every single week practically. And I made these slides a month ago. I made them the day, I finished making them the day that this happened at 10/16. So, but there was a vulnerability that day. There hadn't been one for quite a while, but there was a new one that day. Java, of course, has tons of vulnerabilities, has had tons, and I believe they're discontinuing it, or they're discontinuing Flash, sorry. Windows has had tons of vulnerabilities. I won't go into Mac and Linux. There are all sorts of things. But now we have more. We've got some things, and they're all connected, and they're getting more and more connected. We have things like this egg tray. If you want to know when your egg has gone bad, it'll light up a different color. It'll let you know when you need to buy new eggs. That's cool. You've got this umbrella, which is an unforgettable umbrella. If it's about to rain, you get a little smart notification. Better take your umbrella with you. So if you know, we all look at our phones and don't look up and don't see the rain. But yeah, the Amazon Echo, which is a lot more interesting, makes life easier, supposedly, possibly. People like it. You can order things by talking. You can ask it questions. What's the weather? Should I bring my umbrella? Things like that. You can hack it a little bit. You can do things like have it turn your lights on for you, automate your life, basically. So it's a pretty cool device. It gives you a lot of stuff for free. Listens to you, too, but can profile you. So based on what you're interested in shopping. I mean, of course, all your web browsing stuff is being used as well, but it's another way in, just like smartphones were a way in to our lifestyles and to profiling us for advertising and things like that. It can save past recording data. I mean, it's uploading to Amazon servers, and supposedly there's a possibility of data actually stored on the device for a while, as I'll talk about in a second. So it's not just your voice. It is hearing other voices too. Like there was the instance where a commercial came on and it used the name Alexa, and somehow it managed to order a bunch of dollhouses. So dollhouses were sent to people's houses just from the advertisement into the Alexa without the people's intervention. And they're like $400 US, so really expensive. It could also hear ultrasonic frequencies that we can't hear, so you could design an attack to affect someone's Amazon. I mean, you really just shop for them. I don't think you would do much more, but you can get responses from it. And with physical access, of course, anything is possible if you have physical access to a system. So the Wynn in Las Vegas, at the time of this, they said they were going to add these to all their hotel rooms. And I'm sure they have. I haven't stated a when. But there's another researcher who showed that if you have access to the device, you can just access these pin pads and do a little bit of stuff, which they've released this stuff to replace the bootloader. It looks like that. But you can turn it into an always-on listening device. So they were able to make it so that they could connect to it remotely and listen to what's happening on the Amazon. So stay a night at the Wynn, and you can hack it and have access to everything in that room at that point. Additionally, there was like a case where the police wanted the recordings from the Amazon device, and they started to give them to it, and they have since changed their mind on that. But the police were actually able to get some data out of the device just itself. They weren't able to get everything. And of course, you want murders to be solved, but this is pretty crazy. So there's Barbie. Barbie is online now. It looks like this. But it's supposedly only active on button presses. So you press the button and your child can talk to it and it'll remember what the child says. It sends data back to um, Mattel. I guess that's the company that makes Barbie. And it keeps kind of a profile of the child and what they're interested in. So you can have an actual conversation. Um, the audio is encrypted before sending, so that's great. There aren't any security controls though, and if you have physical access, you can of course mess with it. It can be used as an audio surveillance device. It is connected. It can do video recording. It can also be a communication device. So there's a researcher who has done work on showing all these things happening where they were able to connect to it and talk to the child through the device. It can also be used as a network scanner, which is much more fun for penetration testing. Like you can get access to it, you could use it to see what else is going on inside. So it's also considered, I see it like kind of a watchdog, like this is just a little, from a commercial in the privacy policy. Mattel City has said that they will monitor conversations, and if they see something suspicious, I mean, it's a good thing in one way. If they see something suspicious being said, they'll report it to authorities. But that means they're listening to everything that is happening, and maybe it's not. I don't know, it just doesn't. It's on a weird line. Of course, there are more IoT devices, and people are always finding vulnerabilities. I mean, the companies making these want to give us this convenience, and they want to do as quickly and as fast and as cheaply as possible, but they're not thinking about security. Baby monitors, that's been in the news a lot, where people can connect to baby monitors and yell at the parents or yell at the baby. So those are some fun ones. Well, actually, these are some fun ones. Fun methods of compromise. I was looking at security cameras and found that there's a researcher who did some really cool research. So that car is backing up, and they had to get malware into the network, probably through phishing or something else like that. But then they're able to point an infrared light pulsating at the right level for their malware that's listening for it, and it picks it up through the security camera, which is kind of crazy to think about. And then here's another way of looking at it. They're actually able to leak sensitive data through infrared cameras. We can see it because it's a camera filming it, but the naked eye doesn't know that's lighting up. And they can transmit a book just in a few seconds. So cars, of course, fun to hack. It's all the rage these days. In this case, this is a Wired article, or Wired video. This person in the car is a reporter, and he's just driving his Jeep, and these guys are remotely managing it. They made it so as he's going into the Jeep, into the ditch, he can't use his brakes. And then there's a lot of IoT with law enforcement. So I didn't know about this until I spoke with someone who used to work with a police department in the United States, that the tasers actually they have video on them, and they will, when you walk into the building, they automatically connect and they upload that video just like they do with the microphones and the cameras. They also upload metadata, like if they were discharged or things like that. It's just interesting that those things are online. I haven't had the opportunity to play with that stuff. But in one case, at least, New York Police Department has been testing using Google Glass, as a camera. Usually they just have cameras like right here or somewhere, but using Google Glass as an always-on camera. But then there's, of course, a QR code security vulnerability that was found in Google Glass, and maybe they, if it's still a vulnerability, maybe they haven't updated it. I doubt they would update it. The vulnerability is where it sees a QR code and automatically just goes right to the site or to whatever location. And like, for example, this QR code right here, which I made, will take you to this picture. And then if I was bad or something, I would compromise you in some way, I guess. Those are the fun ones. There's some not fun ones. There's pacemakers, and I'm sure you all know about this research that was done. Those insulin pumps, the pacemakers, it was shown that remotely you could connect to it and force it to deliver a charge that would kill the patient or kill the person wearing the pacemaker. Insulin pumps, same situation. Remotely connect to it and force it to release all the insulin, which would kill the person. So that's pretty crazy. And these devices really shouldn't be connected. I mean, they're connected for updates so the doctors can quickly check them and things like that. But in some of the cases, some of the devices, it's been found when it's been turned off, it's still listening. And of course, the SCADA systems, these are the systems that manage all the industrial control, like the things that make your food, the things that make our products. People get worked up about power plants being messed with SCADA systems, but like dealt with by SCADA systems. But there have been a lot of instances of those things being totally hacked and messed with, but it's a concern. And there have been some instances, like Stuxnet, for example. The ones that do appear are pretty big. And a lot of these things are found online. There are other researchers who do this. They just hunt for this kind of thing, and they just find these online control panels where you, with no access, and you can just connect to it. And they usually look pretty ugly. But I'll talk about a couple data breaches, just to show how, when you get more advanced into protecting data and protecting user information, things like that, how it can become, it's easier to mess up. So like in this case, in 2017, May, the Bronx Lebanon Hospital, just a hospital in New York City, they were compromised via a third-party provider. So this is like you can think of it as a cloud service if you want. So iHealth is this provider. They support them by hosting their backups. So how it happened, it was a misconfigured rsync backup server hosted by iHealth. So rsync is a method to backup data. Discovered using Shodan, which is the search engine for SCADA systems, for things, for stuff. You can find all sorts of great stuff. But someone found this data just out there. A lot of people were affected, 7,000 between 2014 and 2017. Those were patients between those dates. What was taken, things like names and home addresses, addiction histories, religious affiliations, mental health and diagnosis, domestic violence reports, sexual assault reports, HIV status. It's just all out there. Once it's out there, it stays. So, I mean, they did some things wrong. They outsourced their backups without an audit. And I imagine, at one time, you just backed up to yourself to a tape or to servers somewhere else that you control, but maybe it just became easier. And this is what a lot of people are doing. I mean, everything is moving to the cloud, and it's a lot easier to just pay someone to handle it. But they didn't audit that data. Maybe they just took them on their word. I'm not sure. Or they could have looked at their network. iHealth also made mistakes by collecting this data in an insecure manner. And of course, iHealth released a statement that the issue's been contained and there's no inappropriate use of this data. They don't know that, and the issue has not been contained because it's still out there. Even if they fixed it, it's still a problem. The hospital could have done things like audit their cloud providers. Everyone could do that. And perform regular searches of the data. This is sort of a soft penetration testing. And they could have also encrypted that data, which would have been really important. iHealth sort of secure things, perform searches, and basically the same. Ashley Madison, which is a really interesting one. This is a website that was for cheaters. If you want to cheat on your spouse and do it secretly, you can meet up with people. And hopefully actually meet up. Well, hopefully if they want to do that. So a hacking group called Impact Team, I don't know the full motivation, but Ashley Madison said that they had this system in place called full delete. You could pay a little bit more for it. And if you paid more for it and you said, I want my data off there, they'll delete all of you. But it turns out they weren't deleting everything. And one of the reasons Impact Team gave was that you pay charging people for this, and also you're terrible too. So we're going to release your data. We found it, or we've hacked you. They actually access databases that are used by Ashley Madison. The website might have been vulnerable. I don't know the initial compromise method, but they could have phished them. I'm not sure. But the things that were taken, 27.5 million users were affected. Now, these aren't all real users. There's a lot of, it's discovered there are a lot of bots. Mainly a lot of the women on the site were bots. But still, a lot of people were actually affected. And then a researcher took all this data and put it in a place where, you could search a person's name and see if they were actually signed up, which isn't so great because it's caused relationships to break up. And you can actually sign anyone up at that point. You could just, sign your friend up, and then their wife finds out or their husband finds out and think that they're trying to cheat. But things like real names, addresses, credit card numbers, sexual fantasies, the internal company servers were actually accessed. Employee account information was accessed, so it was also employee data, not just the people who were customers or clients. Company bank account data was taken, salary information, things like that. Employee emails, so you can get a lot of great information if you're looking for stuff, more stuff. They had a really terrible response to a lot of denial. They denied every step of the process. Every time impact team said they had something new on them, or anyone asked them what's going on, they denied. But then August 18th, 60 gigabytes of data was confirmed to be out there and released on BitTorrent, shared in the dark web. So this is kind of what the screen looked like about how they're releasing the data. The time's up. We're gonna actually send it out. This is what one of the extracted things looks like. You can go through this and see all sorts of crazy stuff. There's Equifax, which I'm sure you've all heard about. This is only 2 months ago. 2 months ago. A lot of people were affected, mainly US, but also Europe and Canada. But close to half of the United States population was affected. Equifax is, if you don't know, they store your credit history, and they're one of the 3 big companies, or 3 out of 5. There's 3 huge companies that store your data, and we don't really opt in for it. It's just the way it goes. We just they have all of our financial history. So how it happened? There's a vulnerable web app on a website in the U.S. There's an old Apache Struts vulnerability, like this way for to interact with Java, but that's how this breach originally occurred. What was taken was things like names, birth dates, phone numbers, emails, credit card info from a lot of people, dispute docs with privately identifiable information for a lot of customers. Social security numbers was taken. That's our identifiers in the US. It's everything you need for identity theft, which is awesome. So the attackers had access mid-May to June 2017. So that's a good length of time that they actually had full access to all this stuff. The breach was discovered in July, so that's a month later. And of course, at that time, 3 executives sold a bunch of stock after that discovery, but they said they didn't know about it when they questioned about it. We found out about it on September 7th, so much, much later. So in this case, if you haven't frozen your credit at that point, or you haven't locked it down, basically, someone could have been opening credit lines in your name all this time. The options you might have, like free credit monitoring from Equifax. So that's pretty cool. They had a really bad response. Looking at what they did, they set up this domain, trustedpremier.com, and you kind of see a spike because there was suddenly a lot of visits to it. These are DNS queries, because I work at OpenDNS. I get to see about 3% of the internet's DNS queries. So it's a good way to see how things look. But the spike happens when they register it, and then there's this other site, EquifaxSecurity2017.com, which totally looks legitimate. It doesn't look legitimate. It looks like phishing. We actually blocked it until someone mentioned it, and Brian Krebs said we're blocking it, and there was a whole thing, so we unblocked it. And but then there's a whole bunch more domains. They just kept registering more and more domains, really unusual ones, like I think there's like an Equifax security. I saw like 2089 or something like that at one point, like they're looking ahead. But they would host these on different places. They weren't all hosted at Equifax IPs or ASNs that owned Equifax IPs. They would host some of them at GoDaddy. Some of them were with Amazon Web Services. So it really made our job as a security person really, really painful. And then, of course, about a month ago, their website broke again, and they were redirecting users to a fake Flash update. They just can't really seem to get it right. This is the site that was hosting the actual Flash update. And you can see there's a bunch of queries to it. A bunch of people were visiting it because people want to go to Equifax and figure out how to fix this problem for themselves. So I used some data in this from Have I Been Pwned. This is Troy Hunt's site. He makes this, he takes all the breaches that happen and collects the data, and you can type in your email and you can see if you've been compromised at some point. You can also get a notification. There's just a bunch of stuff tons of stuff. I decided to graph it just to kind of take a look at what it looks like. There was a huge breach in late 2008 for MySpace. I'm skipping several of them, but LinkedIn had a large breach at one point. Dropbox had a huge breach in 2012, 13. And Tumblr, Adobe had some email addresses, password hints, passwords, usernames lost. This site, Exploit In, had a breach, very large one. River City Media Online, which I believe hosted ISOs for Microsoft operating systems, they had a breach. Online or spam bot, this was interesting. They actually would collect emails and collect usernames and passwords and things like that and use that for spamming out. Well, they got breached, so it resulted in a breach of breaches. So that was the largest so far up to August. I didn't run this after that. About 7 million. Yeah. So I'm gonna get to the point. I'm sorry, I'm just leading you through breaches. Everything is really terrible. It's gonna get worse. We're gonna have less privacy. I mean, as long as we keep on sending our data out there, but not even sending our data. I mean, we have our phones on us. I don't know. I don't fully trust it. We have devices in our homes that will shop for us, that will listen to us, listen for us. We have personal assistants, and they're getting better and faster, and it's really awesome too. I mean, but it's also terrible. I think we'll have more facial recognition. Like this is. I mean, it's Minority Report. It's cool, but there's already some facial recognition taking place in advertising, but then of course there's tons of it in security controls in airports and whatnot. Now, maybe that's not bad, but maybe it's not good because where is it going to go? You can do things like wear cool makeup and style your hair. I can't, but I can wear the makeup and get a beard. But it still is. It's getting better and better at discovering you. There's ransomware is getting worse and worse. Like it's the easiest way to make money for attackers. So we're seeing more and more of it. We're seeing botnets used to make ransomware and to deliver ransomware and spam bots and phishing and everything. So and the internet's just getting bigger and bigger. I mean, we make so much data every day, and we access so many systems every day. Since 2012, it's really grown quite a bit, like the internet population, the people using the internet, and not just people, but the things using the internet. And it's going to skyrocket after that. I mean, just looking at this graph, I forget who made this. They watch the internet basically and see what's going on. You can see this is every minute of every day. You know, what's an impressive one? Like Amazon makes a bunch of money. Of course, Skype. There's 154,000 calls per minute. Instagram, so many posts, so much media out there. There's just like so much stuff, and now with all these devices, it's just going to get more and more and more. And all your data. I mean, I always worry about like people. Like I think about security and stuff, and I don't want people or the government knowing what I'm doing, and I'm like, but then they probably don't know what I'm doing, but I'm just adding to their profiling of everyone and figuring out who we are. And I don't know. I'm a little bit paranoid. There's going to be a lot more of hacktivism, which is cool and horrible. It's going to depend on who's hacktivizing you. And then there's artificial intelligence, which is looking pretty awesome. Like these robots, the robot that just walked by. But this is really interesting. Like, I know my job as a security researcher, a lot of things I did 10 years ago are being done automatically now, which is amazing. So I'm able to work faster and quicker. As time goes on, I mean, even things I'm working on right now, I'm working on trying to automate my workflow and stop fussing so much over log files, which I hate dealing with all the time. And they're always different. Like, I just want to, I want something else to do it for me. So I know eventually, probably in 10 years or 20 years, if I'm still doing this, I'll be a sysadmin again, and I'll just be managing the systems and the programs that do all this stuff for me. Like, in this case, DARPA did this grand challenge. They had 7 machines. They did a hackathon, basically. These machines, without user intervention during the process, they patch themselves, and they also try to hack the other machines. And as they're hacking, the other machines are patching, and they're hacking, and trying to find and exploit vulnerabilities in these machines. They want to develop advanced autonomous systems that can detect, evaluate and patch software before adversaries have a chance to exploit them. So that's a really neat step in terms of security. It's going to get to a point where it's just going to go beyond what we can keep up with. But it's probably a good thing, at least in that sense. There's a lot of companies that are starting to use AI, whether it's a marketing talk or actually real. There are companies that, like, there's a Cylance is one, I believe, a AV company that uses AI to look at differences on systems. I haven't played with it much, but I've heard it's really useful. In my work, we use some machine learning and a little bit of artificial intelligence stuff to do some really unique things, and I'm surprised to see it make decisions that I would make only at scale, which is cool. And of course, there's these robots, so, like, they're just going to get more and more amazing and super scary. Oh, I guess I'm not. That's okay, I'm almost done. I can't seem to make it go away. I'll let you. Okay. So takeaway from this is really to be better at security, or it's going to cost a whole lot of money for your organization or for you. It's going to cost you time. I have all my credit frozen, so no one messes with it. I have things locked down beyond belief. It's annoying. Don't mess with robots. So that's pretty much it. And if you have any questions, I mean, it's kind of like a lot of stuff, and I didn't go too much in depth. And it's more philosophical than anything else.
Just the starter questions. Schneier recently had a piece on IoT security, and one of the things he said, if you give the internet hands and legs, it will punch and kick. We will see that soon, and you have hinted on that. What do you think? Is it a good idea to connect everything, or?
I don't think so. I mean, I don't put my phone in Bluetooth mode unless I have a reason to. I don't want an Amazon Alexa. Like, I don't want a lot of things. I don't think it's I don't think we're designed for that. But we're designed to have things be convenient and make it easy. But I don't think we're designed for everything to be connected. And there's no reason to. I mean, it's like you're adding more places for someone or something to get in and get a piece of you, I think.